Hello everyone. My name is Erika Octaviani, and I'm from International Program on Science Education, batch 2017. So today I'm going to tell you about the Newton's law. But before that, I'm going to do the share screen to you. Here we go, Newton's law. But before that, I'm gonna specify it into the introduction of Newton's law by me. So what is Newton's law? As you can see, like this law describes the relationship between the force acting on an object and the motion. So it has two factors. The first one is the object and the second one is the motion. And you have to know like who is the scientist who discovered this Newton's law. His name is Sir Isaac Newton, and he said that if I have ever made any valuable discoveries, it has been owing more to patient attention than to any other talent. And the next slide, as you can see, this is Newton's law of motion in physics. The first law said that a body at rest will remain at rest, and a body in motion will remain in motion unless it is acted upon by an external force. So it means like if you want to know that the first law, the object have to be in zero position, zero amount, and then when it have to be impacted by other factor, and after impacted, like it will have the amount of the force. And the second law said that the force acting on an object is equal to the mass of that object times its its acceleration by the formula F equals to m times a. And the third law, for every action, there is an equal and opposite reaction. And the next one is Newton's first law. The first law said that every object will maintain a state at rest or move in an orderly state unless there is a force acting to change it. So it means like in the first law, it will every body that has zero amount. So when you have and it will have force when you give any force to this the first Newton's law. And this law states that if the resultant force or the factor sum of all forces acting on the object is zero, then the object's velocity is constant, mathematically formulated by sigma f equals to zero. And it means that everything will stay still except the force resultant isn't working. The next one is the Newton's second law, that the second law said the change of motion is always directly proportional to force generated or worked and has the same direction as the normal line from the point of contact of the object's force. So as you can see like from that statement, the motion can be changed and always goes into the proportional by the force, and it will have the point of the contact by the object's force. An object with mass and experiences a resultant force of F will experience acceleration in the same direction as the direction of the force, and its magnitude is directly proportional to F and inversely proportional to m, or it can be written as sigma F equal to m times a. And the next one is the third Newton's law. The third law says that the third law statement is for every action there is always an equal and opposite reaction, or the forces of two objects or on each other are always equal in opposite directions. So the third law means that every action is always have the equal and opposite directions by the force by the two objects and that always equal and in opposite direction. And the next one, the forces of action and reaction of two objects have the same magnitude in opposite direction and are linear. In mathematical equations, Newton's third law can be written as F action equals to minus F reaction. So that's all for the explanation of introduction of the Newton's law. If you guys have any further question, you can go into the comment section. So that's all from me. Thank you.